Good evening, good morning, whichever it is. Apologize for not being able to be with you today. I have a little bit of a sickness that I got from my boys, and my wife's out of town, so it's time for us to hunker down and hopefully get healthy here. Um, Depending on where we left off yesterday, you actually may want to skip problem 3. I believe in first period, we did example 3 in class, so you can move on to example 4, or you can see this one done again. I'd be more than happy to explain it to you again. Same with, I believe, 8-6. At any rate, for the sake of the people who did not learn example 3 yet, I'm going to go ahead and give you all that, and then example 4, and then you'll have some time to work on your own. So, we're talking about getting information, comparing information from a graph and from an equation. So here's what you have. You have the distance in y miles. The distance y in miles covered by a rabbit in x hours can be represented by the equation y equals 35x. So here is an equation. This represents the rabbit. Speed. Distance covered by a grizzly bear is shown on the graph over here. Which animal is faster? Explain. Okay, so here's the thing. We're comparing. So we are comparing miles per hour for both animals, the rabbit and this is the grizzly bear over here. Let me change colors just to kind of make it a little bit more visually appealing for you. So grizzly bear is this situation over here. So the first thing I'm going to do is want to compare apples to apples. So you can actually do it one of two ways. You could graph the rabbit, which is a little bit more time consuming and painstaking, so I would recommend avoiding that. The other thing that you can do is come up with an equation for the grizzly bear from this graph. That is definitely what I would recommend. So a couple of things to keep in mind. This is if you go all the way back to the very, very beginning, you notice at the top that it says equations in y equals mx form. So this is a linear equation. Y represents the y coordinate, x represents the x coordinate, m represents the slope. So this is true, and we'll get into slope-intercept next, and we'll kind of show you what that looks like. So technically this is also slope-intercept form, so as long as we're here, we might as well just stop and take a moment. So y equals mx plus b is slope-intercept form, where m is the slope and b is the intercept. And the intercept is where a line crosses the y-axis. So, of course, we've been looking at these lines, and they have been intersecting the origin, which means that the b is 0. So, of course, if it's y equals mx plus 0, then anything plus 0 is just itself, which is where this idea comes from, y equals mx. So, just something to keep in mind as we continue. So the m is the number in front of the x, which represents the slope. So the slope of the rabbit's graph would be 35. And I can very easily calculate using these 2 points the slope of the grizzly bears. Now you can see that time is increasing by 1 hour going across the x coordinate, or the x axis, I'm sorry. And each of these miles is increasing by 10. So right there appears to be 30 miles in 1 hour. So that would be represented by the equation y equals 30x. In other words, I'd be willing to bet that 2 hours, 60 miles, 3 hours, 90 miles. So in other words, the grizzly bear is traveling at 30 miles per hour as compared to 35 miles per hour by the rabbit. So you tell me, which is faster, 35 miles per hour or 30 miles per hour? Exactly. So you can say, it says which animal is faster, and explain. This would be a good opportunity to write a sentence, which is what I'm going to do. I'm going to say, or I'll move this over in a second. The rabbit, whoops, I'm not really sure why that's happening. The rabbit, select. Rabbit is faster because 35 miles per hour, I'm going to say is greater than 30 miles per hour. So let me move this guy out of the way. The idea here is that the rabbit is running at 35 miles per hour, the grizzly bear is running at 30. So obviously the rabbit is faster. All right? Let me kind of briefly explain this next one because it is slightly different from a visual perspective. In fact, I'm going to kind of get you a head start, and then you'll have some time to work on it by yourself instead of just throwing this at you and saying, hey, do this one. So notice there is no graph for the second example here for number 3. There is a table. So same kind of idea. Let's read the whole thing first. Mike spent the amounts shown in the table on tokens at Playtime Games. So there's my table. 15 tokens were $3, 54 tokens are $10.50, 25 tokens are $5, and 36 tokens are $7.20. So the first thing I want to do is remind myself that number of tokens represents the X in the table, and total cost represents the Y in the table. That being said, I could certainly calculate the change in Y over the change in X, and I can take any of these. So this is going to be the Y. We're going to do 3 over 15. And 3 over 15 reduces to the fraction 1 over 5, which would be the decimal equivalent of 0.2. Why is that significant? Well, I'm talking dollars and cents, and by the way, 5 over 25 would give you the same thing, right? Just so that we're on the level playing field, we'll do another one. So 5 over 25 is what we could do. Why is the 5 on top? Because the Y's always go on top. That's what this is telling me here. Slope, constant rate of change, direct variation. Change in Y over the change in X. So again, dividing the top and bottom by 5 gives me 1 over 5, which is obviously equivalent to this fraction, so I'm going to have the same decimal. What does that mean? Well, it means that the cost of tokens for Playtime Games is 20 cents per token. 0.2 written in dollars and cents is 20 cents. Compared to tokens at game time are 25 cents per token. Which arcade has the best price for tokens? I don't like the word best here because that is a superlative adjective which is generally used to represent more than two things. If you're just talking about two things, it should be better. Which arcade has the better price for tokens? So you tell me, what's better, 20 cents a piece or 25 cents a piece? Exactly, 20 cents a piece. So I'm going to say Playtime Games, because that's the arcade that has the 20 cents per token, has the better price because, and very similar to the way that I wrote the one above, 20 cents is less than 25 cents. Very simple. Okay? You make it look better, you can throw a 0 in there. It's probably not a bad idea. So Playtime Games has the better price because 20 cents is less than 25 cents. So per token, Playtime Games has the better deal. All right. And those are kind of the nuts and bolts of that example problem. Now we have a final example that has no visual at all. By the way, if you need to go back and review that, play it again, see it, slow it down a little bit. That's what the video is for. Please feel free to do that. If you're ready to move on, then move on. So here you don't see any visuals. Let's find out what's happening. A 3-year-old dog is often considered to be 21 in human years. Assume that the equivalent age in human years Y varies directly with its age as a dog X. It actually doesn't, but we're going to assume that it does. Write and solve a direct variation equation to find the human year of a dog that is 6 years old. So, a couple of different ways to look at this. First of all, I need to make sure I'm understanding the variables. So, again, it's telling me Y, years Y, varies directly with age X. Okay, so human years Y, sorry, a little more specific, and then dog age is X. In other words, 3-year-old dog. Okay, so I'm talking, this is where it might be helpful to write a proportion, right, and solve a direct variation equation. Okay, perhaps not. So change in Y over change in X is my constant rate of change, or my slope, or my direct variation. So Y is human years. Okay, human years, 21. 3-year-old dog, so dog years 3. That's a nice easy division problem. That's going to give me a slope of 7, or a direct variation of 7. 7 human years per dog year, if that makes sense. So in other words, write and solve a direct variation equation to find the human year of a dog that is 6 years old. So first of all, remember at the very beginning it said that I'm writing the equation in the form y equals mx, where m is the slope, aka the direct variation, which I have found right here. So when it says write an equation, my equation is going to be y equals 7x, because the constant rate of change, or the slope, or the direct variation is 7. So 7 gets substituted in for m. There's my equation. Now I'm going to solve. How old is a dog that is 6 years old in human years? Okay, again, y represents human years. I found that right there. X represents dog age. So I'm going to simply substitute 6 in for x. Let me change colors. Oh, here, we'll do it this way. Y equals 7 times 6. We don't need to change colors. We're just going to substitute 6 in for the x. And that gives me 42. So 42 years in human years. 42 years. Okay? So your 6-year-old dog is 42 years old. That makes sense. Alrighty. So let us take a minute and attack this last example for number 4. I'll read it to you. At a certain store, 4 cans of soup cost $5. Assume the total cost is directly proportional to the number of cans purchased. So in other words, total cost Y varies directly by the number of cans X. I'll help you with that part. Write and solve a direct variation equation first, and then find out how much it would cost to buy 10 cans of soup. Pause the video now and try it on your own. Come back if you need help or when you are done. Alright, we're back. Thank you for taking the time to do that. So here's what we came up with, or what I came up with, I should say. So total cost Y, which means Y on top, number of cans X, X on the bottom. 4 cans of soup cost $5. So the cost of $5 for 4 cans. That gives you $1.25 per can, or 1.25 for the decimal equivalent of this, right? Which means my equation then is whatever the value is here gets substituted in for m. Y equals mx, y equals 1.25x. That's my equation. There's the first part. $1.25 per can, right? So if I want the total cost, it depends on the number of cans. Then it asks, find out how much it costs to buy 10 cans of soup. So 10 then is going to get substituted in for x, right there. And I'm going to multiply 1.25 times 10, which gives me a grand total of $12.50. So 10 cans of soup cost $12.50. Make sure you have it labeled properly with your dollar sign and with your decimals to dollars and cents. And you should be good to go. Again, if you need to review that, go back and see it again. Please do that. Otherwise, what have you learned? Graphs are helpful. They compare different direct variation relationships. You can look at a graph and compare it to an equation. You can look at a graph and compare it to a table. You can create a graph yourself. All of those are helpful in finding direct variation. So you can also find unit rates, which we did. $1.25 per can is a unit rate. 7 years per dog year is a unit rate. So we did that as well. Okay. Here's what we're going to do for the sake of time. I would rather you not do a rally coach today, simply because I don't trust that it's going to get accomplished the way that it should with me not there. So if Mr. Hernandez disagrees with that, he's more than willing to do that with you. Otherwise, you are responsible for, I would skip this. You can skip the rally coach for right now. I want you to use your time to work on page 195 all independently. When you finish that, today is the IXL poll. I would strongly recommend that you spend any remaining time after your homework on IXL I'm going to be checking this sometime this afternoon or evening of Tuesday and getting that done. So trick or treat and have a great day. We'll see you all tomorrow.